charge from infinity to a point, that is potential difference. And when you move the charge from one point to another point, that is electric potential. So for potential difference, difference means some initial and final value. How do you take out the difference? Final potential minus the initial potential. That is work done by the charge. So work done is equal to charge into change in potential. All these things we studied. And V is equal to work done by Q. This was the formula that we discussed, and then we just stopped it here. Let us calculate electric potential for a point charge. See, when there are two charges present and we need to calculate the force, we use Coulomb's law. So class, what have I done here is, this is a charge plus Q, which is a test charge. Now see, electric potential is a property of a single charge only. Only a single charge is enough to have the potential around itself. But class, for the derivation, we need the work done, because potential is completely dependent on the work done. And your work done is dependent on the external force, right? So for external force, forces are not independent properties, are not properties for independent charges. For forces, we require minimum two charges. So that's why in our system, we have brought one more stationary source charge over here. That is just present. Okay. And near it, at this point A, we are bringing our charge from infinity to this point A. So the separation from where this point A and plus Q are separated is R. And at this point Q is at infinity. Okay, so we are bringing a charge from infinity to this particular point, that is A. So the total distance from plus Q to this point Q is X. Okay. Now look, in between I have taken a very small distance. This which you can see, this very small distance I have taken, that is dx. All right. Now what am I doing? This charge is at infinity and I am trying to bring it here at this point A, and I am deriving the electric potential for this point charge. So it's a property of a single charge only. But since we require force for work done, we have to bring one more charge for the calculation. Class, force is never a property of a single charge or any particle. Even when you studied gravitation in the class 11, you have seen there were two masses, m1 and m2 were always present. So this point A and this Q. So these are the things I think I've mentioned, right? R is separated from point A to plus Q, and X is the whole complete distance. So this very small distance, that dx we have taken in between. In between, let's say we have taken very small distance dx, which we can expand on integration. Right? If we integrate it, we can expand this small dx, small value we have, we can expand it throughout. So first of all, we require the force. Can anyone tell me what will be the force between plus Q and small q? Plus Q is there, plus capital Q is there, and small q is there. So these are the two charges that are available, right? And both of these charges are separated by x. So class, now just whenever you have the derivation of electric potential, keep this in your mind. What are you deriving? Electric potential. Electric potential is completely dependent on the work done. Work done has force in it. So from force, recall your Coulomb's law. Okay. So according to Coulomb's law, Ali, you tell me the separation, the Coulombic force between capital Q, small q. Ali? K capital Q small q by x square. Perfect. So when we write the force, force will be K into capital Q into small q divided by x square. And why are we writing this? Because this is the Coulomb's law. For all those whose backup classes are left, Marwa, Ubaidullah, and Aisha, remember our first half portion of the first chapter is still left. Some topics are left. So tomorrow we'll have the class. Okay, you will be informed about the class tomorrow. Because our backup classes were getting slow because of your exams and all. Now we have to cover that up. So Coulomb's law also we'll do it tomorrow. So K capital Q small q by x square. This is the Coulombic force. So we have got our force. Now this is the force. When we use the electric potential, what did we study? that this is the force by the external agent. That is external force. But this is the internal force, right? We are calculating force between capital Q and small q. This is the internal force. Okay, now one more thing. What are the differences between internal and external forces? See class, we have a system. Okay, in your thermodynamics, you must have studied. You have a system. System means the part that is under observation. Like if I just have, let's say I have a phone, this phone is there and a tabletop is there. And I have put the phone on the tabletop. Now what all forces are acting? A normal reaction will be acting upwards, downwards, mg will be acting like this, right? So if this is the case, mg and normal reaction will be the internal forces because they are present within my system. Any other force that is present apart from this internal system, any force in the universe will act as the external force. So right now our system is plus q and small q, right? From infinity to this point r. Basically, we want to expand our small dx that we have taken from infinity to this point r. So for that purpose, we required the Coulomb's law because we have no other option to calculate the force. We don't have electric field. We don't have anything else. So Coulomb's law was the best. But this force is the internal force. Coulomb's law is the internal force between the two charges that acts at the center. So class, in this case, external force will be negative of the internal force minus capital Q small q by x squared. This is according to your third law of Newton, laws of motion. Recall action reaction. So FAB is equal to minus FBA. So your internal force will be negative of the external force and external force will be negative of the internal force. Magnitude can be this. So this is your external force. Now, when we are talking about the work done is formula of work done. Now see, your force is variable. Look, x square. K is constant, capital Q is constant, small q is constant, but your x is variable. One more thing, class, please switch on your videos, all of you. It is already on focus mode. So your external force is dependent on the x. That is the distance. You change the values of x, your force, external force will change. So that's why we are going to use the equation of the variable work done. Okay, the equation that we'll be using will be of the variable work done. Now, when we are talking about the variable work done, this will be F external dot dx integral. Now, from where are we integrating to where? From infinity to r. This is what we are integrating. Now, let us put the value of f external. This will be minus k capital Q small q by x square dx integrating from infinity to r. We have studied integration in detail in the last class, correct? So see, minus k capital Q small q will be taken outside because they are constant terms. So we'll be left with 1 by x square dx from infinity to the point r. Now look, class, when you have to integrate x square in the denominator, it's not correct to integrate it like this, right? Because it's in the denominator and we have not studied any form for this. Let's bring it in the numerator. So it will become minus k capital Q small q x to the power minus 2 dx, integrating it from infinity to r. Now class, what did we discuss? X to the power n is x to the power n plus 1 divided by n plus 1, right? Here x to the power minus 2, you people have done it so many times in the last class also. That is x to the power minus 1, right? 1 minus 2, correct? So here we have x to the power minus 2 is there. This becomes x to the power minus 2 plus 1 divided by minus 2 plus 1. So which is equal to what? Look here. Minus k capital Q small q x to the power minus 1, right? 1 minus 2 is minus 1 divided by minus 1 from infinity to r. Look, this minus and this minus will automatically make this cancel. So this is from infinity to r. Now x to the power minus 1 is there. So it's better we bring it back to the denominator. So it will become k capital Q small q 1 by x. And what are the limits? From infinity to small r. Now let's put it. What is our work done? Work done is K, capital Q, small q, 1 by R, upper limit minus the lower limit, 1 by infinity. So 1 by infinity is 0. 1 by infinity is 0 and 1 by 0 is infinity. So this is infinity. So what is the work done's formula? Work done is coming K, capital Q, small q by R. But this is the work done. We require the potential, right? Potential is missing. So we have studied that potential is work done divided by charge. So from here, the value of potential will be K capital Q small q by R, and this small q here. Small q gets cancelled. Potential is K Q by R. This is the formula of the potential. This can be written as this also, Q by 4 pi epsilon naught R. You can write K as 1 over 4 pi epsilon naught. Now look, what all are these variables? K is the dielectric constant, which is 1 over 4 pi epsilon naught. For the students who I didn't have this Coulomb's law class, we'll be covering it tomorrow. So don't worry about this. In detail, we'll see. In brief, I just told you once, one class which we had, which is 9 into 10 to the power 9. Q is the point charge. Just the point charge. I have not written the magnitude of the point charge. So here you don't have any concept of magnitude because it's a scalar quantity. You don't have to use your parallelogram law that you have to make the first step as magnitude, second step as direction, third step as geometrical construction and all. No. And this is the distance. And V is the potential. Now, if it's a positive charge, it will directly be plus Q by 4 pi epsilon naught R. If it's a negative charge, it will be minus Q by 4 pi epsilon naught R. Here, you won't be careful. You won't be careful. Means do not be careful with the charges. Put it as it is. In your Coulomb's law, in your electric field, you had to put the charges very carefully because you had to put the magnitude. Because you were calculating the direction in the next step. Right now, it's a scalar quantity. So positive for all the positive, negative for all the negative potentials. Simply added, simply subtracted, answer will be calculated very easily. Okay, class. So is this clear to all of you, this derivation?
Can you explain the beginning of the part? I wasn't there.
Yeah, Aisha, let me explain. You see, Aisha, what we are doing is, we are deriving electric potential for a point charge. So we have to take this small q, which is our test charge, which we were using, and we have to calculate its potential. But the problem here is, when we talk about potential is dependent on work done per unit charge. And this work done, this is dependent on force into displacement. So for force, we require one more charge. Force can never be calculated solely, right? Alone, you can never calculate force, potential energies. These can never be calculated alone. So we brought 1 plus capital Q, which is separated by a distance of R at point A. And we are bringing a charge from infinity to this point against the external force, whatever we have studied. And small x is the separation between both the charges. Now, what did we do? We have just taken a very, very, very small point in between from this infinity path to this A point. And we are extending it. We are integrating it from infinity to R. So as to get the entire force. So see, force is K capital Q small q by x square according to Coulomb's law. But the problem is that this is the internal force. Internal force means between our system, plus capital Q and plus small q. But we have studied everything regarding external force, external agent, external. So external is negative of internal. So that's why we wrote it here minus K QQ by x square. Okay? All right. Please write it. Yeah,
Ma'am,
say.
what is meant by property of single charge?
Property of a single charge means that even if only one charge is existing, you don't have any other charge near it. One charge is sufficient to have an electric field around itself and a potential around itself. But for force, it's not a property of a single charge. Force, if I just have one charge, I'll not be able to calculate the force. I require minimum two charges. But for electric field, for potential, only one charge is sufficient. That is what is meant by property of a single charge. Okay.
Yes, ma'am.
Obed, please, you also make arrangements for your videos. The instruction is not just for Ali and Aisha. Okay, class, this is just for interaction purpose and monitoring. Please write it, all of you. And if you have any doubts in between, get it clarified.
Ma'am, to electric potential, can we say potential only?
Can we say
Potential.
electric potential? Yeah, of course, you can say. Electric potential basically means potential due to a charge, an electric charge. That's it. You can use potential. See, you have lots of terms in this chapter with potential included. That's why electric potential I have used. You will have potential energy further. You will have potential difference. Then in current electricity, terminal potential difference. So like this potential word is often used. So if you're able to remember it, potential word is sufficient in itself. Potential
Yes,
difference
ma'am.
is different. Okay.
Yes, ma'am. Ma'am, so force and external force are in opposite direction.
Yes, they are in opposite direction because internal force is getting repelled. Both are positive. External force is trying to bring plus q near. So this is in exact opposite direction.
Yes, ma'am. Ma'am,
Done?
ma'am,
Yes, Obed.
can you explain point charge?
Point charge,
Yes.
electric charge. This electric potential due to point charge, this part.
Yes.
Point charge basically means a charge only. See, when we are talking about charges, charges can be accumulated in different shapes, okay, different objects, right? So only point charges means just a charge. A point charge is present. Or this can be related to if the charges are accumulated in spherical objects. For spheres also you can use all these things. Spheres or point charge. If apart from this you have the charges accumulated in a cube-like structure, in a cone-like structure, then that is not a point charge. Point charge literally means the exact one single charge which has its physical existence in the form of a point, which is very small. Or you can use it for spheres. So you will notice a lot of questions have spheres in them. Okay,
Yes, ma'am.
done?
So it has only magnitude. It is like scalar.
Yes,
So we
charge is scalar. Charge is
so
scalar,
we ignore the
potential is.
values.
So
So we ignore that sign.
we,
Ignore signs. Plus or
no,
minus.
no,
We
no.
ignore.
Here you don't ignore signs. When you just take the magnitude, that time you ignore the signs. Like here you can put the signs also because they are scalar. When you have the vectors, then you have the magnitude separately and direction separately. So in the magnitude part, you ignore the signs. And because you already have the mechanism to calculate the direction. Right now, you don't have any concept of direction over here. So you just directly put the signs as it is. So keep this in mind. In potential, you have to put the signs. All right.
So for minus, we have to put minus.
Yes, like I'll show you a question. Have you written, all of you?
Last one, I'm
Okay, okay, write it quickly. Just let me know once done.
finished.
Okay, look at this. This question says minus 3 millicoulomb is present here, and at a distance of 9 millimeters, you have this point A. And at this point A, we have to calculate the potential. So see, potential's formula is K Q by R. So K is 9 into 10 to the power 9. Charge is minus 3 millicoulombs. So we are going to multiply it with minus 3, not the magnitude 3. Minus 3, and since it is milli will be multiplied to 10 to the power minus 3. So K minus Q divided by R, that is 9 millimeters. So 10 to the power minus 3. 9 gets cancelled, 10 to the power minus 3, 10 to the power minus 3 gets cancelled. So potential is minus 3 into 10 to the power 9 volt. You are going to put the final answer as minus if it is coming negative because of a negative charge. Write this one quickly, then we'll see if you have lots of charges, how we have to manage that. Please write this quickly. Class done?
Yes, ma'am.
Okay. One more thing I forgot to discuss, class. See, your assignments were correct of electric field due to a straight wire. That is the one which most of you have submitted. Just one thing. Ali's, your assignment was fine. In Marwa's assignment, Marwa is there? Yeah. In Marwa's assignment, Marwa, just make the figure. When you have the cylinder, like we had a cylindrical question where you had to prove that the net electric flux is, make the figure so that it is obvious that yes, your area vector is also coming that side, electric field is coming here, so this is 0. Area vector here, so this is 90 or 180 degrees. So make sure that your area vector and electric fields are obvious in the figures. Okay, Marwa?
Yes, ma'am.
Okay. And Aisha, in your assignment, just one thing. When you have the questions like flux, you have to calculate through 1 coulomb of charge. Method is correct, 1 by epsilon naught. But don't leave your answer at that step. See, the question is that much only. It's not a very lengthy question. So in such questions, you are expected to calculate the final value also. So 1 divided by 8.85 into 10 to the power minus 12, calculate that, which will come out around 1.17 into 10 to the power 12, I think, something like this. Calculate that value and then leave your answer at the final step. Okay, Aisha?
Yes, ma'am.
All right. Now, electric potential for a system of n point charges. See, it's very easy over here. It's very easy. What do you have to do? If you have various charges at various separations, let's say this is point P, and you have to calculate the separation between all the charges. Not the separation, sorry, net potential at this P point. Okay. Class, one thing while writing, if you all are turning your videos, then after we begin with the discussion, please put your cameras on. And all of you, not just Aisha and Ali, Marwa also, Ubaidul also. And if you have any specific difficulty in opening the camera for that particular class, just let me know in the beginning. I'll not force you to open the videos if it's uncomfortable for you for that duration of time. Background is disturbing, you are outside or something like this, just tell me in advance. So see, class, when you have to calculate the net potential at a point, let's say at this point P, you have to calculate the net potential. So potential due to Q1 also is there, potential due to Q2 is also there, Qnth is also there. What do? You calculate the individual potentials first. Like let's say V1 here. So K Q1 by R1. Similarly, V2 will be K Q2 by R2. Q3 will be K Q3 by R3. Q4 will be K Q4 R4, like this. When you have nth numbers, so K Qn by Rn. How will you get the net potential then? Simply add it or subtract it. Net potential will be V1 plus V2 plus V3 plus V4 up till nth number. Simply add it. If it is negative, it will get subtracted. If it is positive, it will get added. Basically, which addition is this? This is not your vector addition. This is your algebraic addition. This is the algebraic addition. Okay, so for a system of n interacting point charges, electric potential at a point is the algebraic sum of the potential due to the individual charges. This is the formula. This is the statement, sorry. Okay, and what else? This I'll explain you later. First, write down this part. So this is basically the superposition principle in potential. We'll do the superposition principle for those students who are left. Not tomorrow. Tomorrow we'll focus on we'll complete the methods of charging and the Coulomb's law we'll do. Superposition principle. Please write it, all of you. We'll practice also questions based on this.
Ma'am, can you scroll up? Finish.
Written.
Yes, ma'am.
I'm doing last.
Class C, when we are calculating the work done, potential difference was work done by charge, right? So work done is charge into the change in potential, right? VB minus VA. So suppose a charge is moved from A point to B point. The potential at A point is VA and the potential at B point is VB. So change in potential will be VB minus VA. So work done will be Q into VB minus VA. Ubaidullah, have you written this?
Yes, ma'am.
Okay. So when you have the work done, this will be the formula. You multiply the charge into the change in potential. So this, and one more thing, class, if you have the work done by the electric field, so it will be also negative of the work done by the external force. This is important. This question has once come, electric field one. We will discuss that also in the class. But first, let us discuss this. A very easy question. Plus 10 volt is at A point, minus 20 volt is at B point. And an electron is transferred from A point to B point. Now we have to calculate the work done by the external force. So what's the formula? Work done is equal to charge into change in potential. Charge into change in potential means final potential A to B. So final potential minus the initial potential, VB minus VA. Now, since it's an electron, we'll write the electronic charge, which is E. VB is minus 20 minus VA is 10. So this becomes minus 30 E. This is the work done, this much of joules. So if you want, you should write, in fact, it as minus 30 into 1.6 into 10 to the power minus 19. So this much of joules you will get. One more question, but write this quickly, then we'll discuss it.
Why are we multiplying with that value? 1.6 into 10 power
We
minus.
did this, Ubaidullah. Electronic charge. Remember, I told you the charge that is carried by electron is represented as E, which holds this much value, minus 1.6 into 10 to the power minus 19. In fact, this is negative. You can multiply it with minus also. That you will get the work done as positive also in this case. This much. Remember, I told you that one electron holds this much of charge and one proton holds plus 1.6 into 10 to the power minus 19 of charge. We did this in the conservation of charges. Can
Yes,
you
ma'am.
remember? We did this.
Yes.
So this is the electronic charge. That's why we are multiplying, because the charge here is given as electron. Class written.
Yes, ma'am.
I'm doing. Ma'am, can we also write it as 30 electron joule?
That is exactly not 30 electrons. That is, see, electronic charge is this. So charge has to be replaced. Electron volt is a unit of energy that you will see in the chapter semiconductors and all. That is different. But electron joules is not a unit. So we have to replace it. So this should be your answer. Okay?
Yes.
Written, Ubaidullah?
Yes, ma'am.
Marwa, what about you? You are very silent in the classes. You are understanding everything?
Yes, ma'am.
All right. Let's continue. Now see, the next question says, calculate the work done by electric field in carrying a charge of 2 coulomb from point A to point B. So see, class, when you have the electric field, calculate the work done by the external force as you have studied. So work done by the external force will be charge multiplied to the change in potential. Charge is, okay, 2 coulomb charge is given to us. Q is given as 2 coulomb. So 2 into VB minus VA from A to B. So B is the final. So that will be 2 into VB is 15 minus V is 5. So work done is 2 into 10, which is equal to 20 joules. Now, your work done by the electric field, this electric field is negative of the work done by the external force. So electric field work done by the electric field will be minus 20 joules. Electric field will be minus 20 joules. This is the answer. Write it down. Then one question on superposition principle that we studied now. N number of charges are there that we'll study, we'll discuss. That question is left that we'll discuss.
Ma'am, why is it negative?
Why? Like, because the external work is done against the electric field. The external force is against the force of electric field. So since it is in opposite direction, that's why it is negative.
So this electric field is internal force.
Electric field acts internally. Yes, that's why. Electric field is within the system. Negative here we are taking because electric field and the external work done, they are in the opposite direction. Electric field is within your system internally. An external force is bringing the charge from infinity to that point. So that's why they both are in the opposite direction. So a negative sign is put. And everything is done against the electric field. In our definition also, in one of the definitions, we had it against the electric field. That's why a negative sign is put. So whatever you get, just multiply it with -1 means the negative of it.
So it's always minus. It's
It
always
is
negative.
always minus. It is always minus in the sense, like if I am getting, suppose I got here as minus 20 joules. My external work done came out to be minus 20. Then the electric field would have been minus, that is plus 20 joules. If this was negative, this would have been positive. So this is not something that your work done by electric field is always negative. It is negative of the external work done, means a negative of this one. If this is positive, electric field will be negative, like this example. If this is negative, electric field 1 will come out to be positive. So this is not something fixed that this will always have to be negative. Negative of external work done. And now that depends on your external work done. So you just study the external work done, which we have been using. And then finally multiply it with minus. Okay?
Ma'am,
Yeah?
if one charge is negative, then electric field and external will be both same only.
No. If your charge is negative, let's say work done is coming negative. So electric field will become negative of negative, right? So that will become positive. They'll always be opposite. See, if one thing is negative of the other, so their directions will always be different. Their signs will always be different. If this is negative, this will be positive. Yeah?
Yes, ma'am.
Written. Ubaidullah, have you written?
Last one have been
Okay.
finished.
All right. Now one question based on this. This is an important question and important question, but this is easy class because you just have to add and subtract. Now don't look at the red lines first. Just forget these red lines. Just focus on this. This is a square of side A. 4 charges are put at the vertices of the square plus E minus E plus 2E minus 2. And at the center, we need to calculate the potential. That is our first part. So see, how will we solve? What did we study? Now this is not a single charge present. 4 charges are present. What did I write that time? We have studied that the net potential at a point like this O point will be given by the algebraic sum of potential due to individual charges like A, B, C, D. So let us calculate the potential due to A first, then B, then C, and then D. Then let's see what to do next. So potential due to A. Yes. See class, when you have the, see we need the diagonal, half of the diagonal now. Because this is point O and we need the separation from the charge to the point O. So class, this is like this. This side is A, this side is A, and this is the diagonal AC. Look, this is a right angle triangle. So we can use Pythagoras theorem. So according to Pythagoras theorem, this hypotenuse, that is AC, AC will be under root of A square plus A square. Right, this is what is our Pythagoras theorem. Square of hypotenuse is the sum of square of perpendicular and the square of the base. So this becomes 2A square under root. This comes out to be A root 2. But A root 2 is the complete diagonal. Do I need the complete diagonal? No. We need the half of it till this point 2 because we have to calculate it till this point 2 only. If I had to calculate it at one of the vertices, then I required the full diagonal. But right now I need to calculate it at the center only. So AO, OB, OC, OD, these are required. So see, I'll just half it. So OA is equal to OB is equal to OC is equal to OD is A by root 2. Half of it. I've just half it. I've just halved it. This one. This is coming A by root 2. This is coming A root 2. So when I've halved it, this is coming A root. Sorry, A by root 2. So half of it is A by root 2. Charge is E. This separation is A by root 2. Ali, can you tell me what's the potential at O due to A? Potential due to a point charge. This is a point charge E. So what should it be? Unmute and answer, Ali. What should I write first? Potential due to a point charge.
I'm have to find it O.
What? Potential due to
Wait.
point charge, the derivation which we did in the starting of the class. Final formula, what was it?
Q by X square.
KQ by?
X square.
No.
No, A by root 2 square.
KQ by?
A by root 2 square.
First Ali, tell me this. KQ by. Check, you must have written in your notes. What was the conclusion from the first derivation?
Is equal to KQ by R.
KQ by?
R.
R. Exactly, not X square or anything. KQ by R. See, when you have the force and if charges are identical, that is KQ square by R square. For electric field, one charge gets removed. KQ by R square. For potential, even that R gets removed, one of the R. So KQ by R. Remember this. KQ by R. So Ali, now apply it here at point O due to A. What should I write?
A by root 2.
Yes, exactly. Very good. K. Now, instead of Q, we have the charge E divided by separation from A to O is A by root 2. Correct. Aisha, can you tell me VB? Means due to this B charge at point O?
K
K.
minus
K into?
minus E
Yes, right, correct. Minus E by
A by root.
A by root 2. Very good. See class, this is a negative charge. So we have to take the negative charge itself. Ubaidullah, VC. Yeah, Ubaidullah. Tell me, this is the charge C. What should I write?
2 KE by A by root.
Very good. Perfect. 2E is the charge, K is there. So 2 KE by A by root 2. Marwa, can you tell me for VD due to this?
Yes, ma'am.
VD. Potential due to this charge at point O.
It should be minus 2E.
Minus 2
2E.
2KE.
2KE divided by A root 2.
A by root 2. Right. See, this separation is A by root 2. Charge is minus 2E. So K into minus 2E by A by root 2. Correct class. So now I think you all will be able to write the potentials. Now for the net potential, we have done our first step. Individual potentials are calculated. How do we calculate the net potential? Just algebraically add it. So KE by A by root 2 minus KE by A by root 2 plus 2KE by A by root 2 minus 2KE by A by root 2. Coincidentally, this gets cancelled, this gets cancelled. So net potential at the center O is 0. But it's not necessary. Always you will have this as 0. In this question, it came 0. If you change one of the charges, you will get the potential as something else. Now, potential at point E. Class, this is not a tough question. These red lines that have been marked and at point E you have to calculate. It's just that you have to know the separation. Method will remain the same. Okay, we'll solve it with the same method. See, E, we need the separations with all the charges. Right? Like A by root 2 was here common for all of it. Look, at point E due to A, first you need this separation AE. Right, once you have AE, you will get DE also. And you need the separation for these charges. So see, this whole is A. So half of it will become A by 2. This will become A by 2, right? So we have this separation, means separation between 2E and E point. and E minus E and E point. Like this we know, this we know. Now only these are missing because we need to calculate potential due to plus E and minus 2E. A and D. For A and D, we need these separations. So class, this is not difficult. The way we have calculated it for AC, we can calculate it for AE. The only sides will change. No, this is A by 2. This is the hypotenuse AE. So for the second part, look here. Second part, this is something like this. This is like this. This is your A, this is your B, this is your E. This is A by 2. This is A and you need this. Once you have this, you will calculate D. That is the same. D is the same. So your AE will be under root of A square plus A square by 4. So it will become 5A square by 4 under root. So it will be A by 2 root 5. This is it. This is what is your AE equal to DE. So this is the separation. A root 5 by 2. Okay. I think this is it. 4A square, yeah. A by 2 root 5. Okay. This is what we are getting. Now look class. When we are calculating the potential at E due to A. See, formula is still the same class. K Q by R. We'll write K at point E. We are calculating due to A. Pay attention class. So K E by this AE. What is AE? A root 5 by 2. Okay, so I'm writing here. VA now will be K into E by A root 5 by 2. So 2 will go up like this. Then next, this is B. So K into minus E divided by, what's the separation? A by 2. So divided by A by 2. So VB will come out to be minus KE by A by 2. So 2 will go up. Now coming to VC. VC is also the same. I think the charge is different. 2E is there. So K into 2E by A by 2. So 2 will go up. Or let me make it 2 only here. 2 will go up. Then VD. VD will be, look, VD is this. So K into minus 2E divided by A root 5 by 2. DE is also the same. So what was the charge? Minus 2E. So minus K2E by A root 5 by 2. So 2 goes up. I hope you're understanding why I've made 2 in the numerator. This is divided by 2 so that 2 goes up. So net potential will be 2KE by A root 5. This is minus 2KE by A. This is plus 4KE by A. This is minus, oh, I've written it like this. Just wait. Minus, this is minus 2K. Minus 2K. So minus 4KE by A root 5. Nothing is getting cancelled this time. So we'll take KE by A common. Let's take it common. It's common in all 4 of it. So why to make our calculation so complicated? Let's take KE by A common. Now look what is left when you take common. Take out KE by A from here. You will be left with only 2 by root 5. 2 by root 5. From here, KE by A out, minus 2 is left. From here, KE by A is out, plus 4. From here, KE by root A is out, so minus 4 by root 5. Yeah. So class, from here, this is the net potential. Now let us solve this. KE by A is here. 2 minus 4 is minus 2 by root 5. Right, 2 by root 5 minus 4 by root 5 is minus 2 by 5. And 4 minus 2 is 2. 4 minus 2 is 2. Oh, we can take 2 also outside. 2 is also common. It can be written as 2ke by a. Oh, we could have taken 2ke by a already. 2ke was common in all of it. So we are left with 1 minus 1 by root 5. This is the answer. 2ke by a, 1 minus 1 by root 5. This is VE. Tell me, class, is the second part clear to each one of you? Huh?
Yes, ma'am. But in first part, I have a doubt.
Yeah, ask.
How that became a by root 2?
How
Like
it
we do
see,
a
a
by
root 2 is there. Look, a root 2 is there. We are dividing it by 2. Now you
yes.
have to rationalize it. Whenever you have the numerator as root, we rationalize it. So multiply and divide it by root 2. Root 2 into root 2 is 2. 2a by 2 root 2. 2 gets cancelled, a by root 2. Right?
Why are we rationalizing?
Rationalizing, we always rationalize. In mathematics, whenever you have the numerators in root, you have to rationalize it to simplify. You must have studied rationalizing when you multiply and divide the roots with the same root. And root 2 into root 2 becomes 2. You can solve it like this also. A root 2 by 2. It's the same thing. You will get your answer the same. But it is bigger. A root 2 by 2. So we just, in order to simplify it, like a by root 2 is better to solve than a root 2 by 2. So just to simplify it, we are rationalizing it. This is rationalization. So to get a simpler number to make our calculations easier. Okay.
So we do this when there is a root in numerator.
Numerator, or yeah, when the root is there in the numerator, to just simplify it a bit. Okay.
Yes.
Class, the third part is very easy. It says work done in carrying the charge from O to E. Now, class, don't do this mistake. Many students do this. They join O with this A and try to calculate the work done force and then nothing, class. What is work done? Work done is charge into change in potential. So from O, potential at O is the initial, E is the final. Charge into VE minus VO. That's it. You have calculated VO, you have calculated VE. That's it. Now, class, if a question comes, it can come like this: work done in carrying all this thing directly without mentioning these. So for the work done, you need to have the individual potentials. So third part is very easy. Third part says work done will be charge into change in potential. Charge is electron and change in potential is C. VE minus VO. VO is already 0 at the center. So with this, you just multiply one more charge. E multiplied to this will be 2ke square by A. See, E into E will become E square. 1 minus root 5. This much amount of joules will be left. This is the answer. This is clear. What did I do here?
No, ma'am.
No. See, charge into change in potential is our formula, right? It is
Yes,
saying
ma'am.
from O to E, an electron is moved from O to E. So our formula is charge into change in potential. Charge is electronic charge E, VE minus VO. Now what is VE? VE is this that we have calculated 2ke by A, 1 minus 1 by root 5. This one is VE. VO was
Yes, ma'am.
0. Remember at the center? So this term is 0 already. So if you multiply E to this, what will happen? E into E will become E square. The rest of it will become like this only. From this term to this term, you're actually multiplying E. Got it?
E. E means electric charge. That
Electronic.
1.6
Yes.
into 10 power.
Yes, correct. That is the charge of the electron. Remember that value, Ubaidullah. Otherwise, you'll get confused. That won't be given you in the questions. Is that clear to all of you? Is this question clear to all of you now?
This one.
Ma'am, here, but it is showing proton.
In carrying a proton. Okay. So, protonic charge is the same. Electronic charge and protonic charge are the same. E, same value. So, you will get the same answer. Okay. So, this is a proton. but the value will be the same. Okay?
So can we write E? So here also we can write E also.
Yes. Obedula revised the first class that we had. Remember, I told you electron and protons have the same charge. That is E.
Yes.
For electron and proton. If any other particle is there, then don't use this. For other particles, you have a lot of particles in your syllabus also that can come in the exam. Not here, in your magnetism, that time we'll discuss. Okay, class, quickly write this. Very few minutes are left. Class, your time is up. Do one thing, just take the screenshots and after the class, you can complete writing this. Okay, so quickly, those who have not written, just take the screenshot of this one. Then I'll scroll down. Took?
Yes, ma'am.
And this one also. ले लिया screenshot?
Screenshot.
Yes, ma'am.
And this is the last one. But please write it in your register since time is not left. Otherwise, you'll have to write it after the class. So,
This is a 5 more question.
yeah, Aisha?
This is a 5 more question.
Yeah, this is a 5-marker question. Correct. It depends if the work done is asked, then definitely it's a 5-marker. If only the net potential is asked, it is given in 3 markers also. Because in potential, you don't have the parallelogram law and all. So it comes in the lesser marker questions also, the short answer type. But if work done is asked, then this full one is a complete 5-marker question. Done,
Done.
class? Yeah, Ubaidullah.
Done.
Instead of E, can we also write P because it is proton?
No, don't do that. P represents proton. The protonic charge and the electronic charge is represented by E only. Whether it's your electron that starts with E and proton that doesn't start with E, you have to put E only. Never write P for the protonic charge. That will represent the elementary particle proton. Proton is represented by the symbol P plus. P only, not even P plus. P is sufficient. Like electron is E minus. Neutron is n to the power 0. Like this, where various particles are there, various particles. So this represents the particle, not its charge. Other students, you can leave. We've taken the screenshot already. Okay, we'll meet on Thursday now. No, not Thursday. Aisha, Ubaidullah and Marwa, we are meeting tomorrow. Backup class. Lot of portion is there. Let us complete that also. Okay?
Okay.
Thank you, ma'am.
Yes, ma'am.
All right.
So
Thank you. Yeah, Ubaidullah, you ask. Others can leave.
we just consider their magnitude
Here,
in electric charges for proton and electron.
no, if electron is there, we will use minus E because it's scalar. Work done is also scalar.